you're currently only sharing Yahoo, so can you share the problem that you're talking about?
That's not me, Professor. That's Ola. He's sharing his
Oh,
screen. I don't know.
oh,
Sorry.
sorry.
Yeah, because I only hear your voice, but I couldn't hear what you are doing on the screen.
Oh, yeah. Because I was gonna go over a homework problem, so
Okay, then I will
yeah.
stop the sharing. Then I will stop it.
Okay.
Ìgbọ́ nǹkan ni mò ń sọ, sharing screen.
Okay, I see you have solved for X.
Yeah, I'm trying to write it, but hold on.
I mean, you can also share your screen if it's on the computer. You can also just share your actual.
Well, I didn't have it open because it's on webwork and I didn't get to open it yet. And I don't want to. Sorry.
That's okay.
So I'm just gonna Professor, I'll just send a picture and share it in the group in the chat because it's hard to write on this. Sorry.
Okay, that's okay. That's totally fine. Do you want to do that right now? Actually, I can go over the question that I have that I was going to go over currently, and
Okay.
then that will give you some time to do that.
All right, I'm going to stop sharing.
Okay.
Thank you.
No problem. Okay, so I'm going to share my screen now, and this is a problem about the norepinephrine. There, that's the word. So so if you guys tried your homework problems about exponential growth and decay, there was a problem about how studies show that. Let me show this. Sorry. So there was a study about how to find this, and okay. And so basically, the question was how can I find? Oh, I didn't fully write down this question either. Let me just pull this question up and then see. So far this is a question. I think I saw some of you guys did try this out. Some of you guys didn't get to it, but that's okay. I just wanted to go over this. I wasn't sure if this was too clear. I'm gonna go over something where it talks about the units specifically, because whenever you're talking about any kind of problem, you always want to make sure that the units are the same. And in this problem here, if you guys got to try it, there was you have to pay attention to details. And in the details, you can see that the units were actually not the same. So in this specific problem, you have that it says that norepinephrine. So it says that studies show that the minimum half-life of norepinephrine, I spelled that wrong, is 2 minutes. And then it says that use the following to construct a function that will model the minimum amount of norepinephrine left. It was said left in the body after an initial dose of, let's say, 30 milligrams. So this is a problem that possibly doctors might be using, or anyone like that, because norepinephrine is a medical substance. And so this is kind of like how people can determine how long something will last in your body. And they actually give you a function that they want you to rewrite it as. But based on the problem, can anyone tell me what kind of problem this is without even looking at this function? Just identify what type of problem it is just by the word problem. What's key words? So remember that last time I told you guys that the problem will specifically specify what type of problem you guys will have to use.
Half-life.
Yeah, so we see half-life here. So here we can see that this is going in half-life. So it says that studies show that the minimum half-life of it, and we know that the half-life formula is not this. It's not this because the half-life formula has that 1/2 as a base, and this has an E as a base. So that's the difference between those two formulas. But that means that they want us to rewrite this formula. They want us to rewrite the half-life formula into a formula of this form. So that means that those two should be the same. But before we do that, we have to identify what our components are. And remember that the half-life formula is actually, so if you guys remember from yesterday, the half-life formula is A is equal to P to the 1/2 of T over H. This is from the half-life formula. If you guys have that from yesterday, half-life. So this is the formula from yesterday. If you guys remember, this is the final amount. This is your initial. The half is because it is being split in half. You're kind of determining the half of the life. You have T for time, and H stands for half-life. So now we just have to fill in all of these factors. So you have to find out how much each of them are. So let me go back to the other one. Okay, so now you have to fill in this information in. If we look at this problem, it says that norepinephrine has a half-life of 2 minutes. So this, we already know what the half-life is. So this is for our half-life, and that is 2 minutes. But let's check out what the unit is for the whole problem. So we know that it has a minimum of two minutes, and oh, I didn't write it down. So, actually, so it says use the construct to. Okay, so that is the actual question, and then the actual question is where T of Q. I didn't write this part down. Where T of Q describes the amount, of norepinephrine left in the body after T hours. Have you guys heard of norepinephrine before? I think only doctors know about that. I was debating whether I should go over this question or not, or leave it as a challenge for you guys. I ended up going over it. Just So that's why I don't have it written out completely. Okay, so basically the actual question, it says that, so you want to try to rewrite this, which is QRT, which describes the amount of norepinephrine left in the body after T hours from the initial dosage of P, which is the initial milligrams dosage. So here, if you guys notice, it says that T is going by hours. So since it's going by hours, that means that you have to have the same units. So remember that T is half-life follows the same unit as time. That's what I mentioned yesterday. But hours is not the same thing as minutes. So you actually have to convert this back into the correct type of unit. And so just by looking at this,
60T.
I'm sorry?
60T, will that be fine?
60T? Not exactly, no. Does anyone have any other conversions? How would you guys convert this?
Yeah, 60 minutes make 1 hour. Then 1 minute will be that is 1 hour over 60. Then 2 minutes will be 2 over 60, which is,
yes, 2 minutes will be 2 over 60.
Yeah.
Yes, 2 minutes will be 2 over 60. And then, so that's what half-life is. So our half-life is actually 2 over 60 hours. So now that you guys have the minutes, this one, 2 over 60, is how many hours you have. And that is because, remember that in an hour, so I'm going to write this, in 1 hour, there are 60 minutes. And so because there are 60 minutes in 1 hour, you can say that here it doesn't completely fill up on a whole hour. It's only filling up 2 minutes. So here there's 2 minutes out of the whole hour. So that's why, so since your denominator is now hours, this whole unit is hours. Does anyone have any questions about this unit conversion? This is from conversions, but I'll show you how to convert it if that doesn't really make a lot of sense. So if this doesn't really make a lot of sense, okay, here's another way that you guys can kind of rewrite this. So you know that you want to turn minutes into hours. And you can always rewrite, whenever you guys have something like this, whenever you guys want to do unit conversions, what you can do is rewrite this over 1 and multiply it by whatever you can always multiply it by whatever your conversion is. So since we know that we have 60 minutes is right here. 60 minutes is we're going to want to cancel that out. So we're going to want to multiply this by another fraction that is proportional. And so since we want to cancel out 60 minutes, we're going to put 60 minutes on the denominator. That way we can cancel out the minutes. And then 60 minutes is equal to 1 hour. So we're going to place that 1 hour up here. So our minutes cancel out. So our actual unit is now just hours. And if we multiply across, this is just 2 times 1 hour. So that's 2 over 1 times 60. 1 times 60 is just 60. So this is 60 hours. 2 over 60 hours. This is how you guys can do conversions. And this should have been you guys should have known this from before. So I didn't want to spend too much time on it, but that is how you guys can do this. Does anyone have any questions about this conversion? Okay. All right. So this is what you guys can do for this problem. So now that you have this, now let's actually try to fill in some information for our function. So we are trying to fill in this, we're trying to fill in this equation. So first, let's actually do the half-life formula because we know that that is what we're actually solving for. So if we're doing the half-life formula, we are actually going to just use the information. So what is our given information? From here, we know that our half-life, we have already determined that our half-life is 2/60 hours. And do we have an initial dosage? An initial dose, do we have that?
30 milligram.
Yes. So here we also have the initial amount. The initial dose was 30 milligrams. So we can actually fill in a couple of these things. So if we fill in H, which is 2/60 hours, I don't need to write hours, but I'll write them just in case. And then it doesn't stand for hours. H does not stand for hours. It stands for half-life. And then we can fill in what our initial amount was, which was 30 milligrams. And then we can fill this in. So A should be equal to 30 milligrams times 1/2 of T, which is what we need, over 2/60. So this is what we have so far if we fill everything in. So we notice that this equation is not the same thing as this, but we can also fill this equation in. So the problem is actually telling us to rewrite it in the form of this equation. So now let's try to rewrite a formula that is the same thing as this. So now let's fill in our information into this formula. So this is our QT. So let's fill in this part. Our initial dosage we know is 30. And then E raised to the R, we want to solve for our rate. Our rate is the thing that we don't know at all. And T, it should be our time. Because we want it in as a form, we want to know it as a function of T. So that's how you guys know that that is what that's what your variable should be. So this is going to be R to the T power. And then from here, since you know that these two should be essentially the same, then what you can do is just set both of these equal to each other. So you can set this equal to this and this equal to this, because they are essentially going to be equal to each other. So this is kind of used for whenever you want to try to model an exponential equation in a different form. So maybe you don't want to use this formula. Maybe you want to switch over to something a little different. So you might want to model it in a different form. So if you guys solve for this, you know that what we actually are solving for is the rate. So we're actually solving for the rate because our goal is to fill in this information here. And so if we want to solve for the rate, all we're going to want to do is divide by 30 to both sides, because remember that we are trying to isolate this portion here. So we want to try to isolate E by itself. So 30 gets canceled out, and what we're left with is E to the RT equal to 1/2 of T over 2 to the 60th power. And then from here, you guys learned about how to solve for E. What do you do in cases where you have E? This I taught you guys yesterday. Or
Lane
yeah,
of
ln.
E.
You can take the ln of E, and whatever you do to one side, you have to do to the other side. So the ln of E cancels out. So you have R of T equal to the ln of 1/2. And you can do another extra step here. Since you have ln now, you can bring this up to the front. You can bring the exponent to the front of the equation. So that's going to be T over 2/60, and then the ln of 1/2. So you have this. And now what you're going to want to do, you can actually
Can't we simplify the T over 2?
Yeah.
That would be 30T.
Yeah. So then if you guys want to simplify this part, you guys can, because remember that whenever you guys have a fraction over a fraction, you guys can do keep, change, flip. So I'm going to do that on the side. So if you guys do keep, you guys are keeping T the same, and T is written over 1. You're going to change the operation to multiplication, and you're going to flip the second part. So what this is actually going to be is this is going to be 2 times 60, t times 60, which is 60t, over 2, because 2 times 1 is 2. Remember that you always multiply across. So you can rewrite this as the same thing, but with just 60t over 2. So this is just RT equal to 60t over 2, ln of a half. And then from here, all you have to do is just solve for t. So I'm going to leave this part up to you guys, and then that will get you what r is, and then that will get you, and then you guys can just plug that into your calculators and then find your actual amounts. So that was the tricky part for this portion. And you guys can solve for t from here. For r from here. The main trick part was to try to equate those two together. And then once you guys have your r, you guys can just plug it into that formula, and then that will be the rewritten form of your half-life formula. Any questions about that? Okay. All right, I see no questions. All right.
Professor, that is every time that we always equate the given formula that is different from the real formula. We have to equate it. Anytime we are given any given formula which is different from, this is the given formula, or it's
Yes.
different from the half-life. We always equate it to them. We always equate each
That is
of them.
because so that the reason why you do that is because it's asking you to write an equation that is of this form.
Okay.
So yeah, and so because it's of this form, and you know that this is actually using the half-life formula, that means that these two should be the same. So if these two should be the same, then you can use this information, set it equal to this, and find the missing variables in this equation. Yes.
Thank you.
No problem. Okay. So Sharon, I actually took a look at the question that you have, and I'll share my screen. And that actually is similar to the question that we went over for the last class. It was mainly about one second, where is it? And here it is. Okay, so this is the question that it was on. Was it not this one?
Professor, don't worry. I'll just go to tutoring because I know you have to go on with the lesson. So.
But you can look at the notes from the last time. So I solved a similar question about that.
Okay.
Yesterday. They are in the notes.
All right, I'll check. Don't worry. I know you got to go on. So.
Okay.
Thank you.
No problem. Or you can. So basically, you can take the ln of both sides. That's the essential. You can take the ln of both sides, and then from there, you can do the rest of it.
Okay. Thank you.
No problem. Okay, I can't find it. Okay, but today I actually wanted to go over. Oh, this was the part I wanted to go over. I was looking at yesterday's question. So I wanted you guys to actually practice some where you guys did change the actual formulas, the actual units. There you go. So here you guys have 2 practice problems, and I actually just want you guys to practice some of these problems in class, because we didn't get a chance to last time, and I just want to see what some of your questions are, and then that way we can answer them, any that you have in class. So I know some of you guys did get to try these out, and so some of you guys did do the homework already, and so you guys should be familiar with this. But again, I'll just quickly review. So here you guys know that you have the population of a city, so this first practice problem that you guys have is that the population of a city decreases at a rate of 2.3% per year. So you're always going to want to identify the actual units. So this is the rate, and then it's going by years. So it's going by 2.3% per year. And then the question says, how many years? So now you're looking for what they're asking for. This is the actual question. How many years, speaking of time, years is time, will the population be at 90% of its current size? And then it says to round your answer to the nearest tenth. So since it says that they want you to do 90% of its current size, remember that last time, they don't actually tell you what the current size is. They're saying 90% of it. And last time I explained how if they don't tell you the original size, what you can do is just call that original. Remember that the original stands for P, so you can call that P, and then just rewrite this as a percentage of something. To do that, all you would have to do is find the percent, turn it into a decimal, and multiply it by the original. So that's how you guys can find the original value for that. Are there any questions about that so far? So I'm going to want you guys to try that out. So I'm going to want to try this one out, and then here you guys can do this one too.
Professor,
Mm-hmm.
can we go up? Okay. Okay.
So yeah, so the first thing you always want to do is try to identify what type of equation this is going to use. So what type of formula this is going to use. That's the main thing that you guys always want to ensure of. And you know that you guys are either using so far the formulas that I have taught you guys, the type of equations that I've taught you guys are population growth, population decay. I've also taught you guys half-life and compound interest and compounding continuously. So far, those are the four applications for them. But then you also have their properties.
Professor, are they going to be giving us those formula?
No, these formulas are not given. You guys will have to know these. That's why I told you guys that if you guys do have trouble with remembering the formulas, it's good that you guys write them down and keep them. It's good if you organize your formulas. That way you know when to use them. So you guys can organize your formulas and just write down the formula, write down when you're supposed to use them, and then that way you guys can be a little bit more organized about them. Because at this point, after this point, there will be a lot of formulas, unfortunately, but there are a lot of formulas that are used in math sometimes. So these are some of them. And these are used to model different problems. So yeah, so you guys can try these two out. I didn't realize that I didn't include the units conversion problem. So based off of this, you guys can determine which one to use. And you guys can share your work after you guys are done. And then you guys can also try this one out. But yeah, so you guys can share your work once you guys are done with these. So you guys can share your work if you guys are done with this. How are you guys doing with these? I see that no one has shared their work yet. Are these questions something that you guys aren't too comfortable with? Oh, by the way, guys, if you, I forgot to mention this before. If you guys do not, so in class, I know that sometimes you guys might have questions, and maybe you might be, you might feel shy or not feel like you should ask them, but just ask as many questions as you guys want here, because I'm here to clarify any doubts that you guys have. And so if it's related to this topic, we are currently on this topic right now. So if you guys do not feel comfortable with this specific topic and have questions, you can ask them and I'll be happy to answer them. I don't want to just leave you like completely in the dark. If you guys have questions and you guys don't want to ask them publicly, you can also send me you can also write your question down in the chat and send it to me privately. You guys can do that by just selecting my name on who it's being sent to. And so that's what you guys can actually do. If you guys have any questions about that, because I didn't explain that option before. But yeah, so just ask as many questions as you guys want, because there is no dumb question. There is just room for clarification. So anyone want to participate for this question? So always remember that whenever you guys are turning the percent into a decimal, okay, so let me actually go over these. Whenever you guys are turning, because I don't have anyone that is participating for now, you guys can participate on a different equation. But okay, let me go over this. Since I feel like maybe you guys still need to see an example, possibly. So it says that the population of a city decreases at a rate of 2.3% per year. After how many years will the population be at 90% of its current size? It says round your answer to the nearest 10. So here, all you have to do is fill in the information. The first thing you always want to do is identify what kind of problem is this. So far, which problem did you guys identify this as? Did you guys identify this as growth, decay, half-life?
Decay?
Yeah. So you guys can identify this as decay. So you know that this is the decay formula. Then this means that you guys are going to use A equal to P times 1 minus R to the T power. This is the actual formula you guys need to remember. But again, just as you guys work along with them, it'll be easier to memorize. And then you guys have this, so you guys have to basically just fill in all the information that you guys have. So you guys know that you have a variable missing for A. You guys don't know what A is. You guys don't know what R is. You guys don't know what P is, R, and then T. But remember that T is actually what we're looking for. So T, because it says after how many years will the population be at this size, how many years is the indication that says that we're looking for how many years is going to go by. So we're actually looking for T. So T is what we're looking for. This is our question mark. And we can fill in all of these other components. So A, we can fill in what A is, we can fill in what P is, we can fill in what our rate is. since we know that this says that it's 90% of its current size meaning that we don't know what its current size is. Right now, this equation does not tell us anything about its current size. It only says that when will it be 90% of its current size. If it says it will be 90%, if something is going to be, that's in the future. So that's actually going to be in the future. So this part is actually telling us what A is, but we don't know what the current actual size is. So we're going to label that as P, because remember that P is just standing for original size. And then 90% of this, 90%, remember that to turn this into an actual decimal, you guys are going to take the decimal point and move it over 2 spaces to the left. So then this is actually going to be 0.90. And to find the percentage of something, you're going to turn that into a decimal and multiply it by whatever you're trying to find the percentage of. So 90% of the original, this is 90% of P. This is what this means. Are there any questions about this part so far? So yes. So yeah, then I can see that you guys have gotten the rate. And then for the rate, all you want to do is move over the decimal place 2 places to the left. So if you guys move this decimal 2 places to the left, you guys are going to get that this is 0 point, and then 2 spaces to the left, you're going to fill in any missing values with a 0. So this is going to be 0.023, and this is the decimal place that you guys get. And now all you have to do is just fill in all of this information into the formula. So you guys know that this is going to be 0.90 times P, and then equal to, because that's what A is. So our A is 0.90 times P. And then our principal, we don't know what that is. We're keeping that as P1 minus our rate. Our rate is 0.023, and then to the T power. So all we have to do is just solve for T. This is what we're solving for. T is what we're solving for. So we want to try to isolate the part that has T in it. So we want to try to isolate this part. So what we're going to want to do is divide both sides by P to get P by itself. To get T by itself. So this cancels out our P's. What we're left with is 90.90 equal to this whole inside part. So it's equal to this whole inside part, and then we're just going to take this and solve for T now. And then there's 2 ways of solving for this, as I talked about before, but we can take the ln of both sides. If we take the ln of both sides, this is going to mean that we are actually bringing the T to the front. So remember that anytime that we have an exponent, that's going to come to the front. So this is going to be ln of 0.90 equal to T, because we brought that up front, T of ln of 1 minus 0.23. You guys can put that into your calculator or leave it for now and then just plug the whole thing into your calculator. Whatever you guys want, it's the same thing. And something I didn't actually mention last time, if they actually give you the formula for the equation, one way of identifying if it's population growth or decay is just by looking at the inside of the parentheses. Since you have 1 minus the rate, inside the parentheses, if they have it simplified, it's always going to be less than 1 because you're subtracting by a number. So if the inside of the parentheses is less than 1, then that means that it's decay. If it's bigger than 1, it's going to be growth because the growth formula has an addition sign. So inside the parentheses, if it's bigger than 1 because you're adding, that means that that's growth. And if it's less than 1, it's decay because you're subtracting. So that's kind of like an indication if they have it simplified out for you. And then, so back to this, all you have to do now is just solve for T. T is right here, so we want to get rid of this whole thing. Since this is being multiplied, you want to divide to get rid of it. So divide both sides by ln of 1 minus 0.023, and then you can divide both sides by the same thing, 1 minus 0.023. So then you guys get this. So this cancels out. So T is actually this part over here. So you guys can plug this into your calculator, and that will give you what T is approximately. So remember that T, if you're plugging this into your calculator, that's the approximate value. this is called the exact value. So you guys can plug this in. You guys can plug in ln of 0.90 and then divide that by the ln of 1 minus 0.023, and you guys get 4.53 approximately. Questions? And the unit, what unit is this? You guys can answer in the chat. What unit is this, or out loud, or whatever you guys want. How do I know when to put ln? That is a good question. So you know when to put ln whenever you guys see a little exponent. So ln is usually used whenever you want to solve for a variable that is in the exponent. So here you know that in this question, even though we have p that's missing, that's a variable, but the actual question is telling us how many years are we looking for. So we're actually looking for time. So since t is in our exponent, we want to actually bring it down because that's the only way that we can solve for that. And one way of bringing it down is by taking the ln of both sides. Because remember that once you take the ln of both sides, this actually brings the exponent down to the front. So that's why we can take the ln. That helps us bring down the exponent and actually find the actual value. Does that answer your question? Or is it still a little confusing?
Can you explain it again?
Yeah, sure. Okay. So in this actual question, in this current question that we're actually talking about, it's asking us to state after how many years will the population be this size, right? 90% of its current size. So since the actual question says after how many years, they're asking you how much time has gone by. How much time will it take? So we're actually looking for t. We're looking for time. That's what the actual question is. So our variable, our only variable that we should worry about is t. And here we use p because we don't know what its current size is. It says when will it be 90% of its current size, but that doesn't tell us if we know it or anything. It doesn't tell us anything about its current size. So we're actually just going to use p. P is a variable that you guys can always use if you don't know what the current size is, because remember that p stands for the original size. Since it says that when will it be at is kind of an indication that it's going to be in the future. So when will something be this? That's telling you that that's in the future. So this is going to, they're saying when will it be 90% of its current size? So that's going to be in the future value. To find the percentage of something, you can always just move it over 2 decimal places, and then that will be your decimal. You're turning your percent into a decimal. You can never use the actual percentage in your problem. You always want to turn it into a decimal, so that's 0.90. And then to get the percentage of something, you're just going to multiply it by whatever you're trying to take the percentage of. So that's kind of part of algebra. So this is how you can find the percentage of something if it says that. And I went over this yesterday in an example, but it is okay. And then from here, you guys can take all of your variables. So you know what A is now. This is your A, this is your P, this is your R. All you're going to do is just plug them into the formula. And so this is 0.90 times P, that's A, our P, our 1, and then our rate. And then we're looking for time. So since we're looking for time, this is what our variable is. So the variable is in the exponent. So far, we don't really know of a way of solving for an exponent unless it's at the bottom, unless it's down here. And one way of getting it down would be to take the ln of both sides. But the first thing we did before we did that was get this part by itself. We want to try to isolate this. So to isolate this part, we are just dividing by p to both sides, and that actually cancels everything out. That cancels out all the p's. So we don't even have to worry about that anymore. So this is our new function. This is our new equation, sorry. And so once we have this, like I said, we can take the ln of both sides because we have a variable in our exponent. So once we take the ln, we can bring this t to the front, and then that gives us this new portion here. We have ln of 90 equal to t times the ln of this part. That just gets placed down here. That just gets brought down. And now you're just solving for t. Since t is here and you are actually multiplying by the ln, one way of getting rid of it is by dividing both sides by ln, and so that cancels out, and you're left with t is equal to 0.90 over the ln of 1 minus 0.023. So the essential answer is just whenever you guys have a variable in the exponent, you can always take the ln of both sides.
Yeah, that makes sense.
Okay.
Thank you.
No problem. Okay. So that is how you guys can do that. This second question is a little more straightforward. So I'll actually leave you guys to experiment with that. I know some of you guys tried this out. Were you guys able to find your answers? Did you guys have trouble with that? Okay, let me send out a poll just to see how you guys are doing. This is just like a comparing answers. So instead of I got the same answer, did you get an answer, or were you just or were you completely lost? Or was it just confusing? Okay. Okay. So I'm gonna do the next one just to show you guys how to identify this again. So let's just, so I'm gonna go over this quickly. So then here you guys have this a second problem. So it says that a big company plans to expand its franchise. So even though it's a big problem, don't worry about it. So it plans to expand its franchise, and with this, its number of employees. For tax reason, it is most beneficial to expand the number of employees to a rate of 5% per year. So we know that this is 5% per year. If the company currently has, this says currently, if the company currently has 4,730 employees, it says how many years? So that's what we're looking for. So whenever you guys read how many, that is the part that you guys are looking for. So how many years will it take until the company has 6,000? Until it has 6,000 employees. And then it says to round your answers to the nearest hundredth. So the key thing that you guys want to identify is this growing, decay, half-life, compound, continuously. Which one do you guys think this is and why?
Growth.
Yeah, it's growth. Well, how do you know?
Because it's increasing. So they say it's increasing at a rate of 5% per year.
Yes. And you can also, there are two things that you guys do have. You guys have the word increasing, yes, and it also saying that it's expanding. So you guys can just fill in this information. So you guys know what A is. So you guys know that in the future, they want it to be 6,000. And then currently they have it being 4,730. And then the time, they are asking us for time, but our rate is 5%. Remember to turn this into a percent. To turn from a percent to a decimal, you have to move it over 2 spaces. So that is going to be 0.05, and then you can just plug this all in. So if you plug this all in, the formula is A equals P times 1 plus R to the T power. And then from here, all you're going to do is plug everything in. So you guys are going to have 6,000 equal to 4,730 times 1 plus our rate, which is 0.05 raised to the t power. And then here you just want to, again, solve for t. So whenever you're solving for t in this case is next to this part. So t is corresponding to this parentheses. So we're going to want to isolate this parentheses. That means that we're going to want to get rid of 4,730. So we're going to divide both sides by 4,730 and then divide both sides by 4,730. That looks horrible. And then after this, you guys can get what your solution is by taking the ln of both sides. So, but let me show that in other steps.
Instead of taking the ln, I tried doing log base 1.05.
Yes, that also
that also works, right?
Yeah, that is also an alternative. So that is a perfect alternative for this because they are essentially log and ln are the same because they're both logarithmic functions. The only difference is that ln is a base of e, log base e. So that is why they work. And they work because it's actually the same thing if you guys use the change of base. But yeah, I'll do the log one too. I explained that yesterday, but we can do that too here. So here, if you guys want to change this into the logarithmic form, remember that to rewrite it as log, you guys have log and then base. The base is whatever is at the base of this function. So here's your variable. This is the base. The base of the exponent is the base of the logarithmic function. So your base is 1 plus 0.05. That means that 1 plus 0.05, that's 1.05. And then inside, you guys are going to write whatever's on the opposite side. On the opposite side of the equal sign, you guys have 6,000. You guys have this function here. So I'm just going to copy that and then write that there. And then from there, you guys have it equal to whatever your variable is, which in this case is t. Sorry, whatever your exponent is. In this case, it's t. So you guys can just plug this into your calculator again. And you guys, if you guys have a t at 84, you guys can go all the way down to log base. Click math, go all the way down to log base, put in 1 plus 0.05. And then you guys have 6,000 divided by 4,730. And this is your answer, which is what some of you guys got in the chat. And so yeah, so this is your answer, 4.87. And that's it. Any questions about this? Questions, comments, concerns? All right. So now, so you guys can try to practice the actual homework problems. I didn't really know how. Does this clarify this topic for you guys? I'm not sure how comfortable you guys are with this topic. But I'm not sure what your questions are either. You guys haven't asked many. Okay. So if you guys don't feel too comfortable with this topic, you guys should go to tutoring or ask me questions by email or schedule a meeting with me or anything. Just get help, guys. If you guys do not understand, get help. Yes.
Could you show that conversion thing between the two equations again? Like the way we switch from the half-life thing to the other one.
Yes. I had that as a practice problem, I believe, but I guess I didn't. Give me 1 second. I was gonna have you guys practice, but where did that go? This part. So whenever you're trying to use conversions, you always just want to take, so for example, this 2 minutes. Since we know that this is 2 minutes, we know that in 1 hour, there are 60 minutes. So if you have 2 minutes, you want to essentially cancel out the same units. So since you want to cancel out the minutes and that's in the numerator, you want to put the 60 minutes in the denominator. That way they cancel each other out. So this would just be 2 times 1 hour, which is 2 hours over 60. So 2 over 60 hours.
Perfect. That helps.
So you can always do this in any scenario. And so now, if you guys do not have further questions for me, I will start on trigonometry. But before that, I just want to know how you guys feel about trigonometry. So I laid out a poll for you guys. You guys can answer. How good do you guys feel about trigonometry? Do you feel that you are good at trigonometry? Do you feel like you just need a bit of a review, or do you only get some topics, or it's just, or trigonometry is just something that you guys don't feel too comfortable with and you guys need to go slowly? So again, just answer honestly. This is just for me to know at what pace I should go. Okay. Okay. Oh, so one question is, am I going to go over the functions? Which functions? Oh, yeah. Okay, so let me start with that. So this is today's lesson. And so basically, I am going to go over a review about how to find, I know some of you guys have heard about these triangles before, the 30, 60, 90 triangles, the 45, 45, 90 triangles, all of these stuff. And so basically, if you guys took a look at the video, I showed you guys how to derive these. And so if you guys saw, the 30, 60, 90 triangle actually comes from a equilateral triangle. And in the equilateral triangle, if you guys remember what an equilateral triangle is, an equilateral triangle has all of their sides being equal to each other and all of their angles are equal to each other. That's why it is called an equilateral triangle. So if you guys divide 180 degrees, which is the total number of degrees inside a triangle, by 3, you guys would get that each of the angles are 60 degrees. So in all equilateral triangles, the angles are 60 degrees. And on the sides, you guys have that you guys can name it whatever length you guys want. I decided to name it 2 specifically because of this example. And what we're actually going to do is, to get 30 degrees, we can actually split this in half. We can split this directly along the altitude. We're going to split this triangle in half. And then if we split it in half, we can drag over our actual components. So the 2 is going to stay the same, but 60 is being cut in half. So 60 in half is 30. This angle here, nothing happens to this angle. It is still 60. And this 2, well, it was originally part of this whole size, but if it's being split in half, this is now going to turn into 1. So one question is, am I going to post the practice problems at the bottom of the class? Okay, so yeah, I can post the solutions for the compound interest and continuous interest on Blackboard. So I'll update after each lesson, if I add things on, I usually post them on Blackboard. So I will add those onto the bottom and then I'll post it on Blackboard. And so from here, you guys have this function. So you guys have just basically moved over different things. So you moved over the 2, you split this 2 into 1. And then now, if you guys actually drag these over, this is a missing variable that we do not know. Since we don't know what this is, we're actually going to solve for this. I solved it already, but whenever you guys have a triangle, you guys have the 2 side lengths and you're missing one side, you can always use the Pythagorean theorem. The Pythagorean theorem is used whenever you want to look for any kind of side that is missing. So you guys can multiply a squared plus b squared equals c squared. So you have a squared plus b squared equals c squared. That's your Pythagorean theorem. And your a and b are just your side lengths. So if these are your sides, then all you can do is fill in this information. So you have 1. So you have 1 as being one side, and then this other variable, I called it a. This is your second side. And so since we're looking for this side, we can actually just plug in a squared plus 1. It doesn't matter what order you guys write these in. A could have been 1. This side could have been A, this side could have been B. It really doesn't matter. You can pick one. So I chose this side to be A. So this means that I would have a squared plus my other side is 1. So then I have 1 squared equals C is the hypotenuse. This is the hypotenuse. You can always identify the hypotenuse because it is opposite of the right angle. So if you guys have this as your hypotenuse, then you guys have 2 squared. And then you guys just solve for this. So 2 squared is 4. And then you have a squared plus 1 equals 4. If you solve for a squared, you can subtract 1 to both sides. So this is a squared equal to 3 because 4 minus 1 is 3. To get rid of the square root, to get rid of the square, you can take the square root of both sides. So this is just going to be that a is equal to the square root of 3. So that's what a is equal to. And then from here, you have what your triangle is. So these are the side lengths for your triangle. And I'm not going to get too much into this, but this is another point to point out. If you guys know that these are the side lengths of your triangle, these triangles are actually proportional, meaning that you can multiply any number to the front of this. You can multiply any number to the front of this, and it will give you a triangle with the same angles, because this is called dilation. You're increasing or decreasing, you're scaling it by a number. And this just means that it's going to get bigger or smaller, but it's still going to use the same properties. It's going to have the same measurements proportionally. But I won't get too into that because that's not part of this class. So yeah, but this triangle is proportional. So this is essentially how you guys can get the sides of this triangle. And then you guys also have the 45, 45, 90 triangle. In the 45, 45, 90 triangle, this is actually an isosceles right triangle. It's an isosceles right triangle because 2 of these sides are exactly the same length. If it's 45 degrees, that means that they have 2 of the same angles, which means that their 2 sides are equal to each other. That's why it's isosceles. And so now you guys can identify what this third side is. So I named both of these sides 1. And then this side on top is what we actually are solving for. And so if we solve for what this side is, again, we can use the Pythagorean theorem. We're looking for this side. So we have 1 squared plus 1 squared equals c squared. This is our c in this case. This is our c. So we have 1 squared plus 1, that's 1 plus 1. And then this is equal to c squared. 1 plus 1 is 2. To get rid of the square, remember, we're going to take the square root of both sides. So we take the square root of both sides, we have that c is equal to the square root of 2. So this is what you have up here. So this is how you guys can get the 2 triangles from up here. So you know that this is your 30, 60, 90 triangle. This is your 45, 45, 90 triangle. And from here, we can identify what sine, cosine, tangent of each of these angles are. So I'm actually going to do one with you guys. This is just for review. So if you guys know how to find these, that's great. But so for example, sine, if we look at sine of 30, the angle sine of 30, the angle 30 is on this side here. So if we're looking for sine of 30, we're going to want to label our triangle. We know that sine of 30 is opposite sine. We can use SOHCAHTOA to remember what sine and cosine and tangent are. SOHCAHTOA, from SOHCAHTOA, we know that sine is equal to opposite over adjacent. Cosine is adjacent over hypotenuse. Sorry, sine is opposite over hypotenuse. I think I said adjacent. Sine is opposite over hypotenuse. C is adjacent over hypotenuse. And tangent is opposite over adjacent. And then, so all we want to do is identify what sine of 30 is. So we're going to look at our angle. And then from here, we're going to label our triangle. Anything opposite to 30, that's just saying, okay, what's across? What's opposite of 30? So that's actually 1. So 1 is going to be our opposite side. And then hypotenuse, we know that hypotenuse is longest side. And the hypotenuse, as I said before, it is opposite of the right angle. So that's this side here. So this is our hypotenuse. So we have that sine of 30 is 1/2 because it's 1 over the hypotenuse. So that's how you guys can get that. And then from here, you guys can just find all of these, but I will do
So I will do one more. So then cosine, for cosine, you guys can do the same thing. You guys can do adjacent over hypotenuse. In this case, adjacent just means next to. So what is next to 30 degrees? It needs to be next to 30 degrees, but not the hypotenuse. The hypotenuse has its own, label. So this is the hypotenuse. This is opposite of 30. And this is the adjacent side of 30. So this is for 30 degrees, for the angle of 30. If you guys were to use 60, these sides are going to change names. Now, if you guys were using 60, this would actually be the opposite side of 60 degrees. So that those change in respect to whatever angle you're dealing with. But in this example, you guys have this. So cosine is actually just adjacent. So whatever's next to it is square root of 3 over the hypotenuse, which is 2. So this is what your cosine of 30 is. So cosine of 30 is the square root of 3 over 2. And that's essentially what you guys would do for all of these. I'm not going to go through the whole thing, but that is essentially how you guys can find this table. So one way of remembering, so you guys can always identify what sine of 30 is, sine of 45, sine of 60, cosine of 30. You guys are going to have to remember these. These are things that you have to know as a part of this course. If you guys do not remember some of these, in the beginning, it's fine, but you guys should get used to them as we go along. And from here, there's one way of memorizing these. If you guys remember, if you guys notice that this whole bottom, this table is essentially what you guys will need. And in this table, you guys notice that in the denominator, you guys have 2s, all 2s. All of your denominators are 2 for sine and cosine. So you guys can just remember that all of your denominators are 2. And then in the numerator, this is actually like saying the square root of 1, the square root of 2, the square root of 3. And then in this cosine, it's actually going backwards. It's going square root of 3, the square root of 2, and the square root of 1. The square root of 1 is just 1, so that's why we can just write 1 over 2. So that's one easy way of simplifying and memorizing this. And then for the tangent is something that you guys will have to remember. So you guys will have to remember this column right here, this bottom column for tangent. You guys will have to memorize that tangent of 30 is the square root of 3 over 3. Tangent of 45 is the square root of 1. 1. Tangent of 60 is the square root of 3. So these are the bottom ones that you guys will have to remember, or you guys can remember that that tangent of x is equal to sine over cosine. And if that is true, then another way that you guys can do this algebraically, if you guys can't remember these at all, you guys can take your sine and you can take your cosine and divide them by each other. So for example, tangent of 30 degrees would be sine of 30 degrees, which is 1/2, divided by cosine of 30 degrees, which is square root of 3 over 2. And then that will cancel each other out and simplify to the square root of 3 over 3. And that is essentially how you guys can do this. So this is one way. This is one way that you guys can do this. Another way is by using the unit circle. So there are some people who have learned it with the table, and there are some people who might have learned it with the unit circle. You guys can use whichever you guys feel comfortable with. For the unit circle, in the unit circle, you guys have this unit circle. And this actually tells you all the same values that are on this table, whichever you guys feel comfortable with. These are the exact same values, except here, they have the positive and negative signs incorporated into them, so that's fine. So one thing that you guys have to remember, so these, since it's on the actual plane, on the graphic plane, then it has a coordinate. They're actually stated as coordinates. And your x coordinate actually represents your cosine, and your y coordinate represents your sine. So for example, here, you guys have 30 degrees, and 30 degrees is the same thing as pi over 6. I'll go over how to turn those in a minute, turn those into each other in a minute. And then, so here, if you guys were looking at sine of 30, cosine of 30, let's actually first look at cosine of 30. So here, this is the angle 30 degrees. This coordinate would tell us exactly what our sine and cosine are. So remember that cosine is x, cosine is the x value, so this is our x value, and this is our y value. That means that the square root of 3 over 2 is our cosine, and and 1/2 is our sine. So this is actually what this is. So specifically, we're looking at the cosine of 30 degrees, and here we're looking at the sine of 30 degrees because we're looking at this angle. So the unit circle actually tells you exactly what your cosine and sine are just by looking at the coordinates. So some people may think that the unit circle is easier. Some people may like the table better because they're used to it. Whichever you guys feel more comfortable with, you guys can use. It doesn't really matter as long as you guys can get the exact value. So yeah, so again, this is actually called the exact value for tangent and cosine and everything like that because they have the square roots. And again, if you guys need to find what tangent is, you can again do the same thing. You guys can rewrite sine over cosine, and then that will give you how much it is. And you guys will just have to simplify that. Any questions so far?
Hi, Professor.
Hi.
Yeah, I'm trying to be a little bit confused about the sine, cosine. Can you try to repeat it from?
Yes. So sine and cosine. Was it confusing for how we found sine and cosine? Was this part confusing?
Yeah.
Yes? Okay. So sine, so for example, if we wanted to find sine of 30, okay, so if we wanted to find sine of 30, all we want to basically do is identify what, we know that sine is just opposite over hypotenuse. This is coming from SOHCAHTOA. Some of you guys have learned SOHCAHTOA before, and that just means that sine is equal to opposite over hypotenuse. Since we're looking for sine of 30 degrees is way up here. So we actually want to identify our opposite and hypotenuse side. If we look at our opposite side from 30 degrees, the opposite side from 30 degrees is actually just 1. This is the side that is opposite because you're going across. So this is opposite, and this, in this case, is 1. So you guys have that this is 1, so that's your opposite side. And then your hypotenuse is this angle, is the side that is opposite the right angle. So the side that is opposite the right angle is this side here. So this is 2. This is your hypotenuse. So that is how you guys can get sine of 30 degrees, which is 1/2. Does that make sense? Or is it still a little confusing? Hola?
I think he disconnected.
Okay. All right. So
Yeah, he disconnected.
yeah, I just saw that too. But does anyone else have any other questions about this? So that was just basically kind of like a review of where that came from. But the essential idea that I need you guys to understand is that you guys will basically need to, or either you guys are going to have to evaluate sine of 30, sine of 45, sine of 60. So it's important for you guys to know exactly which each of these values are. And you guys can use either this table or the unit circle, one or the other. Use whichever you want. They can both help you. Hi, Ola. I see that you got disconnected. Were you able to hear that? I'm not sure how far you heard.
Professor,
Mm-hmm.
my screen just went off and I just got it back.
Yeah, I know. I don't know how far you heard. That's what I was trying to get at.
Like this from the triangle, from the triangle.
Okay.
And a square plus just from that place,
Oh, this part.
To where you
okay.
To
Okay. So all we did, okay, so basically from this part. So if you have this triangle,
Yes.
if you have this triangle, all you're going to want to do is split this in half. When you split this in half, this 60 degrees turns into 30 degrees. This angle stays the same. And this bottom side, since it was 2, it gets turned into 1. Right?
Okay.
And this side, here on the side, stays as 2. I already, there's a video about this and how I do it slowly and step by step on our playlist. So you can also watch that.
On the
And then
YouTube?
yes, on YouTube, yes.
Okay.
Yes.
Then, Professor, I want to say some of those examples that you are solving, in the blackboard, is only the YouTube that those solution here. It's not in the lesson note. Maybe
Which one?
send it to us, like the compound interest, the something. Instead of the YouTube also, maybe you send it to the lesson notes.
All of our notes are on the lesson notes.
Okay, like the solutions, the one we are solving now, the problem we are solving, like the half-life and stuff like that,
Yeah, well, the ones that I cover in class, I do whatever I write out in the actual, whatever I write on the actual notes, I upload a picture. I upload the new version onto Blackboard that I write as lesson after. Okay. So I have 2 files on there. I have the one that's before class, and there's one that's after class.
Okay.
And then if you guys share your work, that you guys can see the shared work on the video recording. Okay. So you guys should be able to have access to all of our notes and everything.
Okay, thank you.
No problem. So yes. So that essentially is how you guys can find this table. But again, like I said, if the triangle part did not make sense, you guys can watch the video. But the main thing that I need you guys to understand is that you guys will have to be evaluating these things. So you guys can either memorize the table or memorize the unit circle, whatever you guys want. You guys just are going to need to identify what sine of 30 is, sine of 45 is. And so that you can identify all of those from either the table or the unit circle. That's it. And so from here, all you basically need to do is, so if you guys wanted to turn radians into degrees, a radian is actually represented by pi. So that's actually how many degrees there are. So sorry, I'm just admitting someone in. Okay. So then if you guys have radians, this is represented by pi, and degrees are represented by the little degree sign here. And there's actually 180 degrees in 1 radian. That's the unit conversion. It's kind of like how there's 1 hour, how 1 hour has 60 minutes. It's the exact same thing. So here we're doing something similar to that. So just like before, if we wanted to turn radians into degrees, we have 7 pi over 3. Since this has a little pi in it, this is a radian. So what we can do to turn it into degrees is that we're going to take this and we're going to rewrite it. So pi is going to be in the denominator because we want it to cancel out. We're turning radians into degrees, and the degrees is going to be on top. Whatever you want to turn it into should be on top. So since you're turning radians to degrees, your degrees is going to be on top. That's going to be over pi, so our pi's cancel out. And you can simplify 180 by 3. If you simplify 180 divided by 3, that's 60. So you have 60 times 7, which is 720 degrees. And then from here, that's how you guys can get that. You guys can also just multiply it straight across if you guys are not comfortable with it. You guys can also just multiply 7 pi times 180. So 7 pi times 180, I don't know how much that is exactly, over 3 times pi. And then here you guys can simplify from here. So pi's cancel out. And then you guys can do 7 times 180. And then that's 1,260. And then divide that by 3. And then that will be 420. So you guys get the same thing. So those are 2 ways of getting your answer. So you guys can either simplify it like this or just multiply straight across and then simplify. Whatever you guys feel more comfortable with. Again, there are different ways that you guys can do math. So these are some different options. Whichever you guys feel comfortable with, go with that. Okay. Whenever you guys are turning degrees to radians, if you guys are turning degrees into radians, since you're turning them to radians, remember that whatever you're turning it into, we're turning it into radians, that's going to be on top. So now we're turning it into radians. So the pi is going to be on top and the 180 is going to be on the denominator. So you have 330 degrees times pi over 180. And here you guys notice that the degrees cancel out. So you guys can say that this is 330 times pi, that's 330 pi, divided by 1 times 180, that's 180. And then from here we can simplify this. One way of simplifying is that you notice that there are zeros, so you can always cancel out the zeros. The zeros are kind of like, it's just like extra, so don't worry about those. So you have 33 over 18. You can divide both of these numbers by 3. So 33 divided by 3 is 11. 18 divided by 3 is 6. So this simplifies down to 11 pi over 6. I'm going to show you guys how to simplify this in your calculator. In your calculator, you guys can't just put 33 over 18. You guys can't put 33 over 18. And then here, you guys are going to hit enter, go to math, go to fraction, which is the first one, and then hit enter. And then that's going to tell you the simplified version, which is 11 over 6. So that's how you guys can check your work. If you guys have trouble with simplifying fractions, you guys can try it out and then check your work. Any questions about this? Yes, no?
We can leave our answer on a pi.
Radians is pi, yes. So whenever you guys are pi, whenever you see pi, that stands for radians. And whenever you see this little degree sign, that stands for degrees. So in pre-calculus, you guys are going to be dealing with a lot of radians. In this course, there are radians that are involved. So you guys will have to know how to identify them as radians. And that is the main thing that you guys were going to try. I'm going to try to get you guys to get used to this.
Professor, can you explain this circle again in terms of sine, cosine, and tangent?
This part, yes. So here, essentially, this unit circle is on the coordinate plane. So every point has a coordinate. This is the coordinate at this point. This is the coordinate at this point. And so here you guys can see that 30 degrees has a coordinate. This is the angle for 30 degrees. So x is represented by cosine, y is represented by sine. And that means that the x coordinate in this case is the square root of 3 over 2. That means that this is our cosine of 30. Since this is the angle at 30, this specific coordinate is cosine of 30.
Okay.
And then since our y coordinate is a half, that means that sine of 30 is 1/2.
Okay. Okay. That means y coordinate is always sine, yeah. And x coordinate is
cosine.
Is cosine. Okay.
Yes. And then tangent, if you guys remember from trigonometry, tangent is the same thing as saying sine over cosine. So you guys can take your sine, which is a half. You guys can take 1/2 and divide that over the cosine, which is the square root of 3 over 2. And then from here, you guys are going to do keep, change, flip. So if you guys do that, you guys would be left with 1 over 2 times 2 over the square root of 3. And then you cancel that out. And then I actually rationalized it. So this is for this part down here. This would be equal to 1 over the square root of 3. But I rationalized, which I talked about the other day, to get the square root of 3 over 3. And to do that, all you're going to want to do is multiply both numerator and denominator by the square root of 3. So that simplifies out. to be equal to the square root of 3 over 3. So this is tangent to 30. Yes.
Professor, a quick question. I missed out on this. How did you, on the second question, how did you get the 3?
How did I get a 3? How did I get a 3? Which 3? Sorry.
So you divided 330 pi and 180?
Oh, this part. Okay. So this was coming from the conversion. So remember that whenever we're converting it in from degrees to radians, since we're turning it into radians, radians is what we want to turn it into. Whatever we want to turn it into, that goes on top. So radians is pi, and then the 180 is whatever. Since 1 pi is equal to 180 degrees, you can rewrite this over 180, which is what it's equal to. And now you're just going to simplify it by multiplying. You're going to multiply 330 degrees by pi. That's 330 pi. 1 times 180 is 180. And then from there, you can simplify by just canceling out the zeros and dividing 33 and 18 both by 3.
Yeah, that's the question. Where did you get that 3 from?
Oh, that's because of, that's by the GCF, by the greatest common factor. So this is something that you guys have to think about. So what number can go into both 33 and 18?
Okay.
Oh,
So,
I missed out on that. That's why.
yeah, no problem. Yeah.
Thank you.
So no problem. So a number that goes into both 33 and 18 is 3. So you can divide 33 by 3, that's 11, and 18 divided by 3, that's 6. Any other questions?
That makes sense. Thank you again.
No problem.
That means, Professor, the basic science we need to know of it is the sine of 30, 45, and
60.
60.
Yes.
Both the
Yes.
sine, cosine, and a tangent.
Yes.
30, 45, and 60.
Yes. You guys need to know these. Sine and cosine of 90, 0, and 180, those you can always find on your calculator. Your calculator will always tell you. So for example, you have a sine button on your calculator. You guys can always put in sine of 90 and, oops. One thing, always make sure that it's in degree mode. That way you guys get a clear answer. So sine of 90 is 1. So you guys have that. I'm going to go over that in the next part right now too. So your calculator will always tell you the basic ones like 0, 90, 180. It will always tell you each of those. But yeah. So question. No problem. So I'm gonna go on to talk. So again, these are all in the videos that I already made. If you guys need to go through them again, you guys can either go look at this recording, or if you guys needed to go a little slower step by step, you guys can watch the videos that I have on the playlist already. And then that will take it step by step slowly through each of these processes to review. I don't think I have the one about the unit circle. I don't think I made that video, but that's essentially how you guys can find it. And then for the reference angle, so I'm now going to be talking about reference angles and coterminal angles. A reference angle is basically just any angle that makes any angle that the angle makes with the x-axis. So for example, here you guys have an angle. The angle that it makes with the x-axis is called the reference angle. And so that's actually just going to mean that you're going to want to find what this angle is. And since it's going to be the difference, that's always going to be in the first quadrant. It's always going to be an angle that's in the first quadrant. So it's always going to be between 0 and 90. And a coterminal angle is actually the angle that, any angle that has the same ending point. So for example, let's look at this angle. This angle ends here, right? But since this is on a circle, this can go around a whole nother 360 degrees and end up in the same place. This is called a coterminal angle. So if you go around a whole like 360 degrees, that's going to be the same place. And then if you go around another 360 degrees, that's going to also end up in the same place. So let's say that this is, for example, like 150 maybe. Let's pretend that this angle is 150 degrees. If you go around If you go around the circle a whole 360 degrees, 150 plus 360, you guys can add that up. 150 plus 360, that is 510. So this new angle would be 510. If you go around again, it will give you a different angle, but that is also ending up in the same place. So that is called a coterminal angle. You can go around another time, as many times as you want, and you will always end up in the same place if you go around a full 360 degrees. So if you do that continuously, you guys will get different angles. You can also go backwards. So if you had 150 degrees and you want to go backwards 360 degrees, so now you're going to take 150 and you're going back 360 degrees. So that would be negative 210. So this point would be negative 210, which is actually just going around backwards. So it's still the same angle. You're still going around 360 degrees backwards. So this is negative 210. And the reason why this is, so angles actually go clockwise, counterclockwise. So this starts off at 0, then it goes to 90, then 180, then 270, then 360. And then it just keeps going counterclockwise. If you guys go backwards at 0, backwards, then at this point here, this would be negative 90, negative 180, negative 270, negative 360, or just 0. But they are the same thing backwards. So backwards, so this is back, so counterclockwise is positive, clockwise is negative. That's how you guys can identify these. But if you guys are trying to look for the reference angles, so the reference angles are actually just, as we talked about, they're the difference of it. So for example here, anything, if it is a difference and the reference angle is between 0 and 90, all of the angles in the first quadrant are between 0 and 90. So that means that all of the angles in quadrant 1 are reference angles. But if you have, for example, an angle in quadrant 2, if you guys have an angle here, remember that the reference angle is just the difference between the actual angle and the x-axis. So here you guys want to know how much this angle is. If this is 180 and this is 150, you guys can find the difference between that angle by just looking at by just taking 180 and subtracting it from the angle. Because 180 minus this angle would give you how much this is. Currently, 180 minus 150, that's 30 degrees. So this is 30 degrees according to what I have drawn out. So that's how you guys can get that. And then if it was in the third quadrant, now your actual reference angle is this angle. So what is the angle that is formed here? So what is the angle between your angle and the x-axis? So now you're actually trying to find what this angle is here. And let's say that this was, let's say that this angle is, let's say 210 degrees. And now here, if you want to find what the angle of this is, then you can take 210 degrees and subtract it from 180 degrees, because that will tell you what the difference is. And again, the difference between 210 and 180, if you subtract both of those, that is actually also 30 degrees. So the reference angle is 30 degrees here too. And then if it is in the fourth quadrant, the fourth quadrant is a little tiny bit different, because now you're actually looking for the reference angle, and the angle that it is close to, it's actually close to the 360 degree x-axis. So now you're looking for this angle here. And let's say that this angle is 330 degrees. So here in this example, you guys have this angle, and you want to find the difference between 330 degrees and 360 degrees. So you want to find what this angle is. Again, the angle that is on the x-axis now, the closest one is 360. So you're going to want to take 360 degrees and subtract it from 330 degrees, and that is 30 degrees. So all of these angles in this example have a reference angle of 30 degrees. So that's kind of just like an example that I made. So all of these angles have the same reference angles, but that is how you guys can find all of these. So in the first, so you're just always going to look for the difference. You're looking for the difference between the x-axis. So if it's in the second and third quadrant, you're subtracting either from or to 180. And then in the fourth quadrant, that's when you have to subtract from 360. And then all angles in the first quadrant are the reference angles. Any questions about reference angles or coterminal angles? Questions, comments, concerns? Okay, all right. So I hope that made sense. Now we're gonna try. Now I'm gonna actually do an example without the graph. Well, actually, do I have the graph? No. So here you guys are going to. So here it says to find the reference angle for the following. So we have that this is our angle and this angle is 240 degrees. So we know that from, if we actually graph this out, 240 degrees, where is that angle? Which quadrant is it in? If you guys can identify that, 240 degrees, it's bigger than 180 and it's smaller than 270. So that's actually going to be in the third quadrant here. Yes, so some of you guys did answer that it was in the third quadrant. So since it's in the third quadrant, we're actually going to take our angle and subtract it from 180. So if it's in the third angle, then you know that it's going to deal with 180. Anything that's in the second and third is going to be 180. Since it's bigger than 180, just take the angle and subtract it from 180. That is 60 degrees, and that's exactly what we have here. So that's how you guys can get your reference angle. And then for these, for 495 degrees. 495 degrees is past 360. But remember that we can always get it back within this range by either subtracting or adding 360 or as many times as you want. Since it's past 360, let's actually subtract. So we can take 495 minus 360, and that gives us 135, which is what I already have here. So this is your coterminal angle. This is the coterminal angle that we spoke about, because we can go around the circle and then land in the same place. So 135 degrees is actually in the second quadrant. So originally this angle had gone around 360 degrees and it had ended up here, but it is exactly the same thing. So that's what a coterminal angle is. It just means that it's going around the circle and ending up in the same place. And so in order to find the reference angle here, remember that we're actually just finding the difference. So that means that we're going to take our x-axis, which is 180, and we're going to subtract that from 135. And then that will tell us what our reference angle is, which means that we're going to have to now, oh, that's it. We're just looking for the reference angle. So this is our reference angle. Our reference angle is 45 degrees. Questions about this? Okay. All right. So now let me just, okay. So I showed you guys that, I told you guys that you guys are going to be working with radians here. These are the main radians that you guys will be dealing with. I'm not going to do the conversions for them. I'm going to let you guys, if you guys want to try out the conversions, you guys can try converting to their 30 degrees into radians, and you guys will get pi over 6. That's similar to the example where I made, where I did the conversions from degrees to radians. So you guys can try those out. But so 30 degrees is actually pi over 6, 45 degrees is pi over 4, 60 degrees is pi over 3. And if you guys want to memorize these, one easy way is that 30 degrees and 60 degrees are opposite. So on the denominator, if you see 30 degrees, the denominator is 6. If you guys see 60 degrees, your denominator is 3. So it's actually opposite of what you would think. And then the 45 degrees, this one's just easy. Pi over, it's 45, so it's 4. This is one easy way that you guys can remember this. But again, if you guys don't remember, you guys can always just turn it from degrees to radians. And so by just looking at this, since you guys have that x is equal to 11 pi over 6, 11 pi over 6 is on your is on your coordinate plane. But 11 pi over 6, I'm going to go back to the unit circle. 11 pi over 6 is right here. 11 pi over 6 is right here. But if you guys notice, the denominator is actually going to tell you exactly what your reference angle is. So there's only one option. So 11 pi over 6, that has to have a reference angle of either pi over 6, pi over 4, pi over 3, or pi over 2, or pi. But since it has a denominator of 6, you know that its corresponding, since this 11 pi over 6 has a denominator of 6, its reference angle is going to be pi over 6, and that's just 30. So if it's in radians, it's super easy to identify what your reference angle is just by looking at the denominator, because you're just going by units. Remember that fractions are a part of a whole. You're just looking at a single piece. So if this is 11 pies over 6 pieces, you just want 1 pi over 6. And then for this one, it's exactly the same thing. If you want to find the reference angle of negative 9 pi over 4, again, you guys can look at the denominator to identify what the reference angle is. So in this case, this is going by 4s. So one reference angle would be 1 pi over 4. So that's how you guys can identify the reference angle from radians, which I think might be a little simpler, but so yes, that is how you guys can identify those. So now let's actually go on to finding the reference, finding sine, cosine, and tangent of each of these angles. So from here, we know that this is sine, cosine, and tangent of, we're looking for the value of x. So we're actually going to be looking for sine of 240 degrees, cosine of 240 degrees, and tangent of 240 degrees, because that is our angle. As we spoke about before, we are going to just take this angle and see where it is located. We already identified that 240 degrees is in the 3rd quadrant, so we know that. And then if you guys want to use this table, that is fine. And if you guys want to use the unit circle, that is also fine. Whichever you choose to use, that is perfect. If you guys use, I'm going to go through the example of the unit circle first. So here you guys are going to have to identify what is sine of 240 degrees. Okay, fine. Let's go to our unit circle. On our unit circle, you guys have 240 degrees right here. Sine of 240 degrees, remember that sine of 240 degrees is negative square root of 3 over 2. So that's exactly what this is right here. That's all you have to do. Cosine of 240 degrees. Okay, cosine of 240 degrees is again here. Remember that cosine is your x value. So that's negative 1 over 2. That's exactly what this is here. Tangent of 240 degrees. Tangent, remember that, I didn't copy it down. Tangent of 240 degrees, remember that tangent is sine over cosine. So what you're going to want to do is just simply rewrite sine and cosine into each other, divided by each other. So you're going to want to divide negative square root of 3 over 2 divided by the negative square root of 2. You guys can do that. So for that, you guys can do negative square root of 3 over 2 divided by negative 1 over 2. This means keep, change, flip. So you're going to negative divided by a negative, that turns positive. You're going to have square root of 3 over 2 times 2 over 1. The 2's cancel out. So you are left with the square root of 3. That is where we got this from. So that is essentially how you guys can find this using the unit circle. And then I will go through one example about how to find it using the table. The table is kind of like if you don't want to memorize the unit circle. So if you guys want to use the table, that's completely fine too. For the table, you guys are going to want to find the reference angle first though. So remember that the table only uses 30, 45, and 60. And since we already learned how to find the reference angle for 240 degrees, we found that the reference angle for 240 degrees was 60 degrees. So this is going to be the same thing as finding sine of 60, cosine of 60, tangent of 60. These are all equivalent. The sine and cosine of their reference angles are equivalent. The only thing that you have to be aware of is the sine of each of these. So here, you guys can, so in this first quadrant, all of the signs are positive. Cosine, tangent, sine, all of them are positive in this first quadrant. In the second quadrant, only sine is positive. So sine and its inverse. Its inverse is cosecant, so that's positive too. Everything else is negative. So sine is positive here, but tangent and cosine are negative. In this third quadrant, only tangent and its inverse is positive. So that means that sine and cosine are negative in the third quadrant. In the fourth quadrant, only cosine is positive. So that means that sine and tangent are negative here, but only cosine is positive. And then you guys can remember this this by remembering that all students take calculus, even though it may not be true. So yeah, so that's one way that you guys can remember this, and that's just remembering the signs. And then in the table, you guys can identify those. So you guys know what sine of 60 is. The sine of 60 is the square root of 3 over 2. But since it is in the since this is in the third quadrant, is sine positive here? No, because only tangent is positive. So this is going to be negative. We also know that cosine in the third quadrant is negative. So cosine of 60 is 1/2, but it's negative. And then tangent of 60 is the square root of 3. So that's how you guys can identify both of these using two different methods. You can use either the unit circle or the table, whichever you guys prefer. So that is how you guys can do that. And I'm gonna send out a poll just to see which one you guys feel more comfortable with. And that is, so the question is, which one do you feel more comfortable with? Do you like the unit circle better, or do you like the table better? And that's just kind of like a way for me to identify which one you guys like better. All right, so I got a pretty much tie between. Oh, okay, never mind. Now the table is winning a bit. Okay, so yeah, so it depends on how it might be biased to what you learned before. So usually people tend to like the things that they learned first or second, but so it depends on whichever you prefer. If I saw more likely towards one, I would have chosen. Yeah, there's a tie. Okay. There's a tie between which one you guys prefer. So that's fine. You guys can use whichever you want. Okay, I'll do one more. So in this example, you guys have x equal to 11 pi over 6. 11 pi over 6, remember that to find the reference angle, you're just going to look at the denominator. So if you wanted to find the reference angle for this, you just look at the denominator. So this is the same thing as sine of pi over 6. Cosine of 11 pi over 6 is the same as cosine of pi over 6, and then tangent of pi over 6. All you have to be aware of is the signs again. But 11 pi over 6, this means that your whole top part, remember that pi is equal to 180 degrees. So it's actually splitting up 180 degrees into 6 pieces because that's your denominator. So 1, 2, 3, 4, 5, 6. So these are your 6 pieces. And so you can actually count those to get to 11 pi over 6 if you want to figure out where it is. So you guys can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11 pi over 6 at this point here. And this is in the fourth quadrant. So that's how you guys can identify exactly where this is on your quadrant. And if you guys have the unit circle, you guys can also see that 11 pi over 6 is here on the fourth quadrant as well. And so just going off of this, you guys can identify cosine. You guys can identify sine, cosine, and tangent. So we know that 11 pi over 6 is in the fourth quadrant. In the fourth quadrant, we said that, which one is the only one that's positive? Let's see if you guys remember. Oh, I kind of have it there. Yes. So in the fourth quadrant, only cosine is positive. And so since cosine is positive, cosine is the only one that's going to be positive here. All of the other ones are going to be negative. So remember to put a little negative sign in front of that. And then, okay, so I'm going to use the table for this one. And then I'm also going to do the unit circle. So sine, so we're looking for sine of pi over 6. Sine of pi over 6 is 1/2. So that's going to be negative 1/2. Cosine of pi over 6, cosine is the square root of 3 over 2. So that's how you guys know that. And since it's in the fourth quadrant, it's positive. So positive square root of 3 over 2. Tangent of pi over 6 is the square root of 3 over 2. And since it's in the fourth quadrant, that is negative. So that's how you guys can identify all of these just by using the table. And again, so whenever you guys are using the table, you guys need to identify first their reference angle. If you guys are looking at the unit circle, if you guys wanted to identify it on the unit circle, okay, fine. Go to 11 pi over 6. Your cosine. Remember that cosine is your x and sine is your y. So sine of 11 pi over 6, that is negative 1/2, which is what we have. Cosine of 11 pi over 6, cosine is our x, so that is positive square root of 3 over 2. And then tangent, this is where you guys have to do a little bit of algebra, and you have to divide negative 1/2 divided by square root of 3 over 2, and then that will give you negative square root of 3 over 3. So that is how you guys can identify those. Any questions about this? I'm not going to do the keep change flip because I feel like you guys are okay with those. You guys can practice those if you guys need to. So I definitely recommend that you guys practice those. But are there any questions about this so far? Okay, I'm going to do one more. I'm going to do the negative case. Sorry. I'm moving things a lot. Okay. I realize that I'm moving things a lot in this lesson, sorry. So here you guys have a negative angle. So here, if you guys have a negative angle, remember that your negative angle just means that you can add a whole 360 degrees around, and 360 degrees is the same thing as, so if pi is equal to 180 degrees, that means that 360 degrees is equal to 2 pi. So that's how you guys can identify that. But if you guys add, you guys can either do that or just go on the circle. But remember that the unit circle, if you guys use the unit circle, it will tell you this. Let me copy this down because I didn't copy it down. Okay, so I brought down my little unit circle. I'm gonna have to shrink it. Okay, so this is my unit circle. And this is my other table part. Okay, so let's actually do this. So remember that so I'm gonna do the table first. If you guys want to use the table, remember that if you have your angle, you're gonna wanna find the reference angle. To find the reference angle, all you need to do if it's in radian form, just look at the denominator. The denominator here is 4, so that means that your reference angle is pi over 4. So this is going to be the same as sine of pi over 4. But again, you want to make sure that you know exactly where this is on your quadrant. So we're going to go to negative pi over 4. Negative pi, remember, since that's negative, we're going to go clockwise. So this is going to go, it's our graph this time from 180. Half of the graph is going to be divided into 4 pieces. So you have 1, 2, 3, 4. You're dividing these up into 4 pieces. And then the other half, you're also dividing them up into 4 pieces because it's 1/4. And so we're going to go. Okay, so this is negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, 4, 5, 6, 7, 8, 9. So this is negative 9 pi over 4. So one question is, in our test regarding these questions, do we need to answer all 3 in one problem? I haven't looked at the, I'll tell you guys more about that tomorrow. I haven't looked at the individual problems themselves. You may have to. I haven't found questions where they are singular and they only ask you for one. I will try to look. I'll try to keep looking for those and see if I can find something that is similar to that, because I'm not a coding expert, and and behind webwork there's actually coding behind that, so I don't know how to modify that exactly to only give you guys a certain portion of it. So if I can't find a problem that has only to identify sine and cosine and tangent, then I will possibly have you guys identify all three. But you guys should have practice with all three. So again, all of the questions that I assigned for your test are either similar to or exactly from your homework. So you guys should have practice with your homework, and then that shouldn't be too bad. But yeah, I'll try to, I'm still gonna try to keep looking for some that have singulars. So that is still undetermined. But yeah. No, but again, I'll try to make the next test to be the same as the other test, but I'll announce that tomorrow. I'll talk about the test tomorrow.
Yeah, Prof.
Yes.
Professor. The circle here, Q1, Q2, Q3, you said because it's negative?
Yes, because it's negative, it's going
we start from 0 backward.
Yes.
Backward, then we say since it's over 4, that will be over 4 is that's 180 over 4.
Yes.
That is
so that means
30,
that you're
30. Is that it? Or
30?
That means the quarter of this, it's 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yes, that's how we got to negative 9 pi over 4.
Oh, okay.
Yes, so that is exactly how we got to that. So
Okay.
remember that.
That means we divide this by 4. We divide
Yes.
it to, okay, 4.
So since pi represents 180, we're actually dividing half of this by 4 pieces. So we're dividing this half into 4 pieces. That's 1, 2, 3, 4. So that's how you guys can divide it. And this other half is also 180. So you're also dividing this into 1, 2, 3, 4. And that's how you guys can identify this.
Okay.
So remember that in fractions, each of these side pieces are exactly the same angle because they're all equal to each other in a fraction. So that's how fractions work. So inside these parentheses, you do not need a negative. Inside these parentheses, is that what your question?
Yes.
Oh, sorry, this is another question. So someone asked a question about if there should be a negative pi inside these. What you can do, if you want to add the negative sign on the outside, you guys can add the negative sign before in this step. So since it's in the 4th quadrant, you know that in the 4th quadrant, you want to specify which of these is positive and which of these is negative. Since cosine is the only one that's positive here, where you can write the negative sign is on the outside, because you're actually making the negative value on the outside. Because first you're evaluating sine of pi over 4, and that is the square root of 2 over 2, and then you're just saying that that is negative. And then cosine of pi over 4 is the square root of 2 over 2, and then tangent of pi over 4 is 1, and then since it's in the 4th quadrant, it's negative. Okay. The reason why you cannot add it into the inside is because then that changes, well, technically, not really, not too much. I guess you can write it either or, either inside or outside. So I have another question that says, so sine and tangent are always going to be negative. So sine and cosine are only going to be negative if it's in the 4th quadrant. you guys have to remember which quadrant they're positive and negative in, and you can use that by using this. So you can say that all students take calculus, or which may or may not be true. So all of them are positive in the first quadrant. Only sine is positive in the second quadrant. That means that tangent and cosine are negative here. In the third quadrant, only tangent is positive. In the fourth quadrant, only cosine is positive. So since we're in the fourth quadrant, yes. So since we're in the fourth quadrant, only cosine is going to be positive. Sine and tangent are going to be both negative. So it depends on what quadrant you are looking for.
Oh, okay. That's why. Is that why the this cosine something become positive here? But in the question is -9 over pi minus 9 pi over 4. But the answer we got there is plus square root of 2 over 4 or over 2.
Yes.
Is that why it's positive? Because it's at
it's positive because it is in the fourth quadrant. And
quadrant.
cosine, yes, and cosine is positive in the fourth quadrant. So we know that since cosine is positive, so we know that this is going to be positive. And we're just going to look at our table. If you are looking at cosine of pi over 4, cosine of pi over 4, that is the square root of 2 over 2. So we have positive square root of 2 over 2. That's coming from here.
Okay. Professor, this -9 pi over 4, is it the same thing as plus cosine pi over 4? Because we say it's equal. Because this is pi over 4 will be 45, cos 45.
Can you repeat that one more time? I'm sorry.
Yeah, I say pi over 4 is pi is 180. 180.
Yes, pi is 180.
Over 4 that is 45 degree. 45 degree.
Yes.
45 degree. Okay. And the cosine of 45 is square root of 2 over 2.
Yes.
Over 2. Okay. How about this -9? Do we not where has it gone to? Where has it gone to?
So this is called, pi over 4 is called the reference angle. We use the reference angle if you guys want to use this table. If you guys are using this table, you guys can use the reference angle. And all you're going to want to do is take the 4, because the reference angle is going by units, it's going by whatever's in the first quadrant. You know that it's only going to take one of these pi over 4s. So it's only going to take one of them, which is pi over 4. So that's here. So it's going to go, that means that all of these are going to be broken up into 4 pieces. 180 is going to be broken down into 4 pieces. This other half is also going to be broken down into 4 pieces. So that is how you can answer that. And then if you guys wanted to use the unit circle, if you guys were on the unit circle, you guys can go backwards as well. So that would basically mean that, so if you guys were at -9 over 4, so it's actually the same thing. If you guys know that it's 45 degrees, you guys can look at the 4s. So you guys can look at these. So it's a little, so these actually have a set unit value, but so for example, -9 pi over 4, that is going to go, remember that is actually going forward like this. So you guys would basically have to count the same way. So this would be -1 pi over 4, 2 pi over 4, 3 pi over 4, 3 pi over, and it just keep going. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would end up in the same place. So that is exactly how you guys can do that. Are there any questions about this so far? Any other questions? I'm sorry. Okay, so I am going to have you guys practice 2 of these. So you guys are going to find sine, cosine, and tangent for the following angles. So you guys can find these 2, and then you guys can share what you guys get. So you guys can again use either the reference, you guys can either use the table or the unit circle, whichever you guys want. So I just saw a question that says that that if you added 2 pi to negative 9 pi over 4, you would still get a negative value. That would be negative pi over 4, and that's correct. If it is still negative and you wanted to make it positive, you can add another 2 pi again, and then that will give you the positive value. So you can add and subtract 360 as many times as you want until you get between 0 and 360, if that's what your goal is. So you guys can try these out and then share your work.
Professor,
Yes.
can you show us that student, the first quadrant that's positive, negative? Okay.
This one?
Okay, everything. Okay, okay, that's good.
I'll copy this down.
Okay. That means, Professor, that means x is equal to 120. We have to find the sine of it, cosine of it, tangent of it.
Yes. So
Okay.
depending on which one you choose to use, if you choose to use the unit circle, you can identify those by looking at the specific angle. And then you can also find tangent by taking, I didn't copy it down here, by taking sine over cosine, that's one way. Or you can find the reference angle and then find it using the table. Whichever you prefer.
Okay.
I'll this table too.
Okay.
Let's
120. Okay.
So remember that you're finding the reference angle if you guys are looking for this using the table, but you mainly have to look for sine, cosine, and tangent for each of these angles. So you'd have to find sine of 120, cosine of 120, and tangent of 120. And then sine of 5 pi over 4, cosine of 5 pi over 4, and then tangent of 5 pi over 4.
Professor, it doesn't allow me to share the.
Oh, sorry, that's because I am currently sharing. Okay. Give me 1 second.
Okay.
So you can share a portion and then I will share someone else's work to also
Okay.
give other people a chance to share.
Okay.
So we'll look at, Ola, which one are you choosing to share?
That's number 1, A.
Okay. Oh, you guys both have this. Okay, it's fine. I mean, as long as you guys share, I'll still give you guys a participation fee. So it's fine. So I see that you guys both have the same, actually. Yeah, you guys have the same answers. So here, you guys, if you guys still share your work, and even though you guys, if we don't get a chance to go over it, I'll still give you guys participation points. So don't worry about that. So here, you guys do have, so Ola, can you explain your work a little bit, please?
I should explain?
Yes, please.
Oh, yeah. The first one is x is equal to 120 degree. And we take sine x, and which is sine 120 degree. And sine 120 degree on the table is the same thing as sine 60 degree.
Okay. How do you know?
That's 180 minus 120. That is equals to 60.
Yes.
And that is sine 60. And sine 60 on that table is square root of 3 over 2. When I look at the table, is square root of 3 over 2. Then the cosine, since it's a cosine of 120 will also be cosine of 60 degree. They are the same. And cosine of 60 degree on that table also is half. And the same thing on the tangent. The tangent of 120 is the same thing as tangent of 60. And on the table, the tangent of 60 is square root of 3. And since all 120 falls within the positive area, That's why all the answers are positive.
Yes. Okay. So all of your answers are positive because, can you repeat that one more time? Because it falls in which quadrant?
Is in the second quadrant. Is in the second quadrant, and the sine, the cosine, and the tangent, they are all positive in the second quadrant.
Okay, so in the second quadrant, you can see that in the second quadrant, only sine is positive.
Yeah, yeah. Only sine is positive.
So that means that cosine and tangent are going to be negative. So you should have a little negative sign in front of.
Negative sign.
Yes, in front of negative. I can't write on your paper. But you should have a little negative sign in front of your 1/2 and in front of your negative. So it should be negative square root of 3 and negative square root of 2. Sorry, negative 1/2. Yes.
Oh, okay.
Yes.
Because of that, the student, yeah, it's true.
Yes. Yes. All students take calculus. Okay. So did anyone have any questions about this? Okay. Sorry. So what about number 2? What about the second one? Did anyone have their answers for the second one? Did anyone want to share their work for the second question?
I found the file with the second one.
Okay. Yes. So for the second question, I'm going to share the work for this and share my screen for this one. Okay, so this is for the second question. And then for this question, would you like to explain your work, Maya, or?
Yeah, so 5p over 4 is 225 degrees, which is in the third quadrant, and the sign is going to be negative in the third quadrant, so it's going to be negative sign of p over 4, and it's going to be negative square of 2 over 2. And the same goes for cosine. It's going to be negative 2 since it's in the third quadrant, and it's going to be also negative square root of 2 over 2. And the tangent is going to be positive. It's in the third quadrant, and it's going to be tangent of p over 4 is going to be 1.
Yes. Great. Does anyone have any questions about this? Okay. All right. So yeah, so essentially this is how you guys can find the sine, cosine, and tangent for each of these. And then from here, you guys can identify these. The calculator on my phone and the actual calculator here. So there is a question about how you download the calculator you downloaded on your phone and the actual calculator are different steps to get answers. What steps on your calculator? Oh, on your calculator, you always want to click on mode and then click on degree. Let me go to show my screen for that. So thank you, Maya, for sharing. And then for the question about the calculator, whenever you guys have a calculator, you're dealing with trigonometry, you always want to make sure that you go to mode and make sure that it is on degree mode, not on radian mode. If it's on radian mode, you guys have to switch it over to degree mode. So always make sure that it's highlighted. You always have to make sure that this little degree is highlighted. And then you can type in your cosine and sine of everything. But most of these questions will ask you to find the exact value. So they will ask you for the exact value, which means that you guys have to identify what it is in radicals.
Okay.
So yeah, so the calculator, if you guys put this into your calculator, it will give you decimals, which isn't the exact value for this, because that's a rounded off error. But okay, so we will continue talking more about this tomorrow, which is the trigonometric part, and then we're gonna actually start to graph these. So now you guys know how to identify the reference angles, and then tomorrow we're gonna talk about graphing the sine, cosine, and tangent of these. So if anyone has any other questions, you guys can ask. If not, we will call it a day. So does anyone else have any other questions? Okay, so yes, so I will continue to hand out the grades on Blackboard, and I actually posted, well, I allowed Blackboard to show you the grade letter that you have currently, but it is not completely accurate. And for those of you who are having finished grading your exam, it isn't fully accurate. So I will upload those, and then you guys can have a better understanding. But I won't leave those up there for too long because those aren't exactly accurate. I think for some reason it's not actually the scale for that. You guys can always find out the scale for A, B, and C for the percentage online on the City Tech website, and then you guys can do that. Okay.
Thank you, Professor.
No problem. So I wish you guys to have a good day. Have a good day, everyone.
You too.
I will see you guys tomorrow. Okay. Bye, guys.
See
You guys
you.
have homework practice then.
Thank you.
Bye-bye.